Hello, can you guys hear me?
Yep, we can hear you.
Hi, I think it's time. Certainly didn't expect this many people show up. Um, and I actually didn't prepare that much for this section because it was just something that came up 2 days ago. Uh, and and I did ask internally whether it'd be fine to talk with the same community about this, and the answer was yes. So I just put it in here. Um, so. Uh, Just a bit of background information for people who are not very familiar with this area. So currently the uh, x86 instruction emulation is done inside the hypervisor. And the code is written in C, and file itself is 12,000 lines long. And x86 instruction emulation has been a source of security issues in the past, and in the future there may be more security issues. So I think it'd be good if we can increase our security posture by moving this thing altogether into user space. So that's a bit background on Zen, and internally in Microsoft we have an experimental project to port a cloud hypervisor to run on Hyper-V. Send the link here. So cloud hypervisor is it's not really a hypervisor. Just think of it as a QEMU that's written in Rust. And one of the requirements on Microsoft's side is to do the instruction emulation in user space.
As an interjection, do you strictly mean in user space, or do you mean outside of the main hypervisor context? Because
In
those are
user
two
space
subtly different things.
in user space within the emulator.
Okay, so you're specifically trying to move instruction emulation down beside the device emulation.
Yes, that's right. And also on the KVM side, there's a patch series to actually disable in-kernel x86 instruction emulation. I believe they are looking into this sort of thing as well. So I'm basically just wondering, what do people think about doing this in a Zen system?
So I have a few opinions and ideas here. First of all, I do not think it is possible, even in things like a second generation VM and other situations, for you to get rid of emulation completely. There is just too much stuff that the hardware does not do for you on VMexit. Everything to do with checking that a single step gets delivered properly at the end of an instruction. At the moment, there's a huge swathe of bugs in hypervisors because hardware doesn't do that automatically for you, and then the behavior changes depending on whether you take a straight intercept into the hypervisor or take an instruction emulation path. In particular, for Zen, we've discussed this at previous summits. I was looking to attempt to unify the intercept handling and the emulation handling, so they both had a common tail for doing interrupt injection, exception handling, and all of that. That is required to fix some bugs in introspection and generally providing architectural behavior to the guest when it hits a CPU ID instruction, for example. I don't think things like that can ever be taken out.
What if when you hit a CPU ID instruction, you also pass that VM exit back to user space, and that user space handle it? It doesn't have to be done inside the hypervisor, not all the logic, right?
Well, that depends on your model. When you've got introspection enabled in Zen, that's exactly what happens. We take the CPU ID trap, we pass it to user space, and user space goes and does stuff with it.
Yep.
However, there are enough cases that you need to get right in the state, and you can either have one single piece of logic doing that correctly in the hypervisor, or you can require everyone else to rewrite it. And the bug we have in Zen at the moment is that it behaves differently depending on whether you take the intercept path or the emulation path. And that there are practical things like you will take a VM entry failure if you do not get this right, and we've had security issues based on that in the past.
Right, but it's not really an all or nothing approach. If has to be some part that's done inside the hypervisor, well, so be it.
Well, so the other thing you get to is the straight up performance reasons for doing it. I totally accept that there will be people who want to reduce emulation for security boundary reasons, and I think there are things we could do to generally reduce that. You are never ever going to substitute the actual intercept handling. So the intercept handling must be completed by the hypervisor or passed to user space, because these are actions you cannot not do. So on that side, you have to do them in the hypervisor, or you have to pass them to user space. And passing them to user space is certainly fine. You may get increased security via that mechanism. You definitely get reduced performance via that mechanism, and that's a valid trade-off that people might choose to take.
Yep.
Yeah, especially with KVM, you might be not hit such hard as with Xen, right? Because on KVM, you have the QEMU process running on the same physical CPU in theory. So your vCPU is more or less a kernel context of the QEMU process. But on Xen, you need to either have some user process somehow associated with the vCPU on the same physical CPU, which would be really dramatic change in DOM0, or you have to take into account scheduling as well in DOM0, and this might be rather hard, because when you have got 20 vCPU guest and only 4 vCPU DOM0, you will have problems in some times.
So
I guess the other question is, what kind of emulations do we expect to see? Of course, on this scale, you've got introspection on one side, where we can emulate any arbitrary instruction that happens to have a memory operand hitting a protected memory region. all the way to instructions running on no execute pages because they're being tracked by the introspection agent. So for introspection, we definitely need the support for all instructions. And bear in mind, when we say x86 emulate in this case, for the FPU operations, what we actually mean is decode and replay. It's not that we have open coded all the SSE and the AVX logic. All we do is we decode the instructions and pull operands out of memory, replay them against a local buffer. So it's not like we have a massive quantity of written C implementing instructions that the processor supports. Go ahead.
Yeah, the problem is, I think this would be an all or nothing, right? So either for everyone emulation in userland or for nobody. So PD domains, for example, have some parts where they in boot phase where they might write to page tables with native instructions. And this is deadly with emulation, so the boot times will explode.
Mm-hmm.
And even more for PD.0, there is no user mode at this time. So you need to have in hypervisor emulation when you want to support any kind of PD domain, in my opinion.
Yeah, the PV emulation is never going away. Page tables are a good example, but fundamentally you can change the PV guest not to do that. You can't, for example, change the PV guest not to use in or out instructions. So we actually get rather more interesting emulation via the GP fault path than the page fault path. I think it's reasonable for you to say that an enlightened VM should get down to a minimum amount of emulation. These days, where you've got X2 APIC available, possibly sped up in hardware, and you're not doing anything interesting introspection-wise, it might be reasonable to get to the point of saying we do not expect any general-purpose MMIO traps, for example.
Yep. And also consider, well, I know Zen emphasize heavily on traditional kind of VMs, like the operating system can do anything or everything that it sees fit. But if you consider, say, if you just want a VM for isolation for compute, and you somehow have a high confidence that the kernel or what the kernel, guest kernel will do and will not do, you don't actually need that many instruction emulation paths inside the hypervisor at all. Like the x86 instruction emulator inside Zen is really trying to be all and do all, but it's yes, it's required for traditional kind of VMs, but in reality, if you run a fully, it's not fully virtualized, but fully enlightened VM,
a cloud native OM,
cloud native, yeah, you don't actually need all that code.
I think it would be. I agree with your point. There are VMs we would like to run that should not hit the majority of emulation. I think it is reasonable to try and put in a security barrier there to say this VM is expected not to use general emulation. I think that would be fine. It is going to guarantee to hit things like the CPU ID trap, the MSR traps. Intercepts. So the bare minimum to make that work is going to be necessary, again, whether it's handled in the hypervisor or handled off in user space elsewhere.
Yeah, but in those use cases, you can actually just say we don't want it to take the in hypervisor instruction emulator. We want it to take a different path.
Right, but I mean, it doesn't under Zen at the moment.
Yeah, and then it Zen would expose a different kinds of VM exit that would provide enough information for the user space to do things with it.
So specifically, at the moment in Zen, we have two totally orthogonal code paths. We've got the ones that come from the instruction intercepts, and we've got the ones that come from general emulation. And this in practice means you get two different behaviors depending on how exactly you came to run the instruction. And also, it means that you get different corner case behavior when, for example, you're introspecting a write MSR to something that the introspection agent is interested in, depending on whether it's running on no execute pages or not. So from that point of view, what I wanted to do was to combine the intercept and the emulate path by having, because essentially an intercept is just a bit of an intercept is an instruction where the hardware has already told you something about it. So what I really wanted to do was split x86 emulate into two parts, where you have first the decode and the gathering of state. And the second part was doing the instruction. And it's quite easy to fit intercept into the middle there. So your intercept comes along and says, hey, here is all the information that exists about this instruction. It's a write MSR, here's your index. At which point we would end up with only one code path that is the how do I deal with this write MSR. And it might be go to the guest write MSR function, or it might be hand off to user space for the introspection agent to look at, or maybe in a third mode, it's always hand all of this state to user space. But then you get to the end of the instruction that says, right, I have now completed, there was no fault, I move EIP forwards, I check for pending single step, I check for interrupt injection on return to guest. Because the thing is, you're going to take VM exits for things that are not related to guest instructions, and you still need to do things like single step pending checks and interrupt injection at that point. So even for things that are not an instruction emulation, you still have to do these final stage activities. And the problem Zen has at the moment is that the way we go about doing those depends on how you got to that path, which is why I'm trying to unify all of them.
Yeah, I think that would definitely be a good idea. I mean, regardless whether we want to move the instruction emulation into user space or not. Yeah.
So I guess the question would actually go out to people of a more introspection point of view. Is it something we think we could extend the introspection API with? Because that's already got an interface where we pass most of the general purpose registers and some other decoded information about what's going on. So it's an interface that already looks rather like something we would use to pass details into user space.
Wouldn't expanding IRX be kind of more natural to this?
Maybe an IREC v2 that does not share most of the bugs that the current IREC structure has. But in theory, yes.
Yeah, we will have to come up with a new structure somehow because MSRs, as far as I know, are not forwarded to the emulator anyway. So we would have to come up with something new anyway.
Well, no, at the moment, all MSRs are handled in the hypervisor, but they may be forwarded to the VMI introspection, so that there's a hook for introspection to say, hey, tell me about this MSR. And there's even the bitmap of MSRs the introspection agent is interested in to prevent forwarding most of them.
I also wanted to ask whether this will also include the decoding of the instruction, so that you would forward all the registers and then let the VM exit information, I guess, or something like that, and the guest will do the decoding, or are we going to keep the decoding in Zen and then just forward, send a normal IOREC like we do now, where the decoding is done in Zen?
So at least on the things I work on, you need to do the decoding ourselves. So inside user space. But yeah. Anyway, never mind.
And that's not too difficult. What you do is you pass
pass the whole stream to
CS and RIP to the guest. You also need to pass the segment cache, which you get out of the VMCS and VMCB, and that gives user space enough information to know where to look in the guest to read to read the instruction stream. So then this emulator in user space will have access to the whole guest memory anyway. Will need to be
yes.
Yeah, it will have to. Right. There's no way it cannot.
Yeah.
And in terms of experiments, so it actually only takes it takes emulating a few instructions to boot Linux and Windows with this model, like all the move instructions. That's provided all the guests are enlightened.
So I know that Bromium have done a lot of work in this area, and they did a slightly different model. They came to the conclusion that for performance, you really need to have MOV emulated in the hypervisor, but most other instructions can be emulated as a series of MOV instructions. So what they actually do is hide a little bit of hypervisor logic inside guest context. So anytime you take an exit and have a complicated thing to emulate, it actually re-enters guest context. It's an SMM-like thing, but it's rather better hidden and not standards compliant at all. And what they do is they redirect to that bit of logic which does the instruction decode and emulate inside guest context, and just issues a subset of MOV instructions, each of which then is quite simple and easy to do in the hypervisor. So that was a trade-off between moving most of the emulation out but retaining the bits they actually needed for performance reasons.
So I believe there's optimization for that as well, at least in the design we have at the moment. Yeah, more specifically, just like like you said, for the move instruction, that sort of thing.
Yeah. To be perfectly honest, I have been pestering Intel to get MOV decoding in an intercept for at least 6 years now, and they still don't seem to know whether it would be useful or not. They keep on asking for performance numbers. It would frankly help massively to hypervisors if plain MOV instructions could be decoded like the VMX instructions are, for example, and have the hardware VM exit pass you the information about which is the source operand, which is the destination operand. But that doesn't exist on any hardware at the moment.
Yeah, so I still don't have a very good sense on whether this is something that the Zen community would be interested in. I mean, after we talk so much, I mean, we've gone into a lot of details. Yeah, so.
I think Andy's suggestion, well, Andy's, the thing that Bromium does of moving it inside of the guest seems very interesting. I mean, we already have a special pages that we use, so we could probably load something there and then jump into it and do the decoding there or something like that. And it will probably perform better than moving it to DOM0 user space.
Yeah, in the Zen model in particular, you've got latency associated with the double scheduling, and I know the Bearflank people have a different idea of how to try and fix the double scheduling problem. From my point of view as an x86 maintainer, I would be very happy for people to experiment in this area. I know that in reality, the use cases that pay my paycheck will depend on it being faster rather than perfectly secure. So I think this would be interesting for Zen to have. I'm not entirely sure whether it would be massively widely adopted, and I think that would come down to use cases and risk profiles.
Mm-hmm. Yeah, that's fair enough.
I think if you're actually looking to reduce attack surfaces, particularly in Linux, it might be better to get second generation VMs or things like that that only ever need the MOV instruction, and we can terminate it completely if it steps outside those bounds. I think that might give you a better general reduction in attack surface. At which point you're then in the position where most of your VMs can run like that, and your other one that's still introspecting can still actually run the logic in the hypervisor if it needs to. I think there's definitely use in saying this VM is expected not to require general emulation. But I'm not entirely certain how that would look right about now.
Okay.
Okay, asshole.
Corey, did you want to say
Sorry,
something?
I'm talking to my dog. I didn't realize I was it randomly mutes you or not mutes you when you join. I'm sorry about that. I thought I was muted.
And do we have any other people from some of the more security focused areas, cubes of OpenXT or derivatives thereof? I know cubes in the past have expressed an interest in not having any emulation, but that unfortunately led to a security issue.
Wait. Okay.
The reason PVH guests have an option for not emulating the local APIC was because of a blind wish to get rid of all emulation, except that doesn't work with how hardware behaves with the task priority.
I see. So I thought you were talking about x86 instruction emulation. Okay.
Well, I mean, the point there was to get rid of, was to stop the use of the emulator, because it's an MMIO window. Therefore, we have to do general emulation to access it. That's the other thing. Emulation is quite ambiguous. As far as I'm concerned, you are never ever taking LAPIC emulation out of the hypervisor, because it has been a standard in x86 CPUs for 30 odd years.
Yes, that's right. Yeah. So I was just specifically thinking about more specific. yeah, just x86 instruction emulation in general on the ML region, that sort of thing. But yeah, this still not trying to do the do it all kind of stuff. I certainly don't want to move everything out of the hypervisor. Like you said, there has to be at least some portion inside of it, either for architectural correctness or for performance reasons. But there could be other use cases that in which performance is not that important.
So from a Fidelis standpoint, and by extension OpenXT to some degree, emulation is of concern. I know from my perspective, there's other areas I'm more focused on getting resolved in terms of security than the emulation. We are, I've been briefed on the Bromium approach, which Andrew just briefed here. And that one actually is very interesting because it keeps the emulation inside the context of the guest in which that operation is being interpreted for.
Mm-hmm. Yeah, that's really an interesting approach. Yeah.
And in particular, an approach like that doesn't require you to have some extra thing running in DOM0 to make it happen, and that's an advantage in some use cases. And of course, I realize it's not helpful for this specific topic that you raised, where you need everything together for Cloud Hypervisor, but it is certainly one approach. I certainly think it would be good if Zen could have the option of rejecting general emulation on a per guest basis.
Okay. Yeah. It just came to me that actually there's a thing called Windows Hypervisor Platform, and yeah, say if you look at just one moment. Right. Sorry, no, wrong page. Yeah, so if you look at the page, this is basically what Microsoft does today, at least on Windows. So just information, I'll give you some background idea, information on why I bring this up. But anyway, it's just out of my curiosity to bring out this topic with the Zen community, and I certainly don't have time to actually work on it, but to learn a bit more about this topic from Zen's perspective is rather helpful, at least for me.
For the more security-focused people, would getting to a point where only MOV emulation exists be something that people would generally be interested in?
Yes. So reducing what's in the hypervisor, and also isolating what more riskier parts as well, such as the emulation.
And bear in mind that even with just MOV emulation, you've still got to have the entirety of the segmentation logic and the entirety of the page table logic still there and working, because you're still working under virtual addresses rather than physical addresses. So there is more code than just the straight how do I deal with a MOV.
Right. But you're no longer, everything else that you've ejected to get down to MOV, it would be a dramatic decrease, right?
I think it would be a decrease in attack surface. Exactly. I'm not certain how much of a decrease in total code volume it would be.
Right. So the potential of bug is still there. The potential of how much is exposed to the gas decreases.
So on the subject of security vulnerabilities, it is certainly true that we have had issues in the past. However, I'm not aware of us having had a security vulnerability in the emulator since we actually put together a working AFL harness for it. Now, talking of, I should run that before 4.14 gets out of the door. But yeah, seriously, if you can find a bug in the emulator, we'll fix it. It's just we tacitly think we've found all of them at the moment, or at least fuzzing seems to indicate that we don't have anything lurking.
To the degree that the assumptions you made with the fuzzer.
You are the fuzz harness is in the tree. You can go and look at it and see if you agree with some of the changes we made. Well, we didn't make any changes to the instruction emulator. Whether there are different ways you'd go about fuzzing it.
I mean, I think that the question is because the fuzz harness fundamentally can only detect crashes when running in Ring 3, and so there may be other kinds of security issues that other kinds of attacks that behavior that could lead to an attack that the fuzzer is not detecting. I think that's the idea.
Right. So to put the theoretical hat on for a moment, the larger your surface is with the larger code base which increases your potential for a bug, raises your risk. So, on our standpoint, we want to reduce that risk as best as possible without making it completely unperformant. So if we can reduce the attack surface or reduce the exposure to the guest, we may not be able to reduce how much code is there and thus the potential for a bug, but we can at least reduce the chances of a guest being able to get to that bug.
So sorry, I was kicked out of the room, so I missed the last few minutes of what you guys spoke about. But
what was the last thing you heard?
I think I was kicked out after I pasted in the link to the Windows Hypervisor platform.
Oh, so when he went quiet and we started talking.
Right.
Okay,
so
yeah.
In the meantime, we've discussed a little bit about the AFL fuzzing harness, which actually everyone can thank Wei for. He started it.
I know George started it, but I make everything, integrate everything in the tree. So credit where credit goes. Okay. So I've get all the information I needed. So thanks guys for coming. And the next session also is on by me, so I think I'll need to take a short break. And thank you guys.
Yeah, we've got 6 minutes, I think, now on the next session, and it's also in this room.
Okay.
All right. Thank you, Wei, for starting this conversation.
You're welcome.
Thank you.